Solving equations using balanced strategies. So when we solve equations using balanced strategies, it requires an imagination, or I think it does. It might also require a lot of practice from previous learning. So for example, questions like I wish or I want that term to be canceled out really do help out our conversation with this. I would ask you to maybe get this internal dialogue going in your head. So here's something to keep in mind, though, that the final destination for solving an equation is to get the unknown variable isolated to one side. So here's a balance strategy that I'm going to use. And by the way, it's a balanced strategy. I'm going to put it on a scale and it balances out. So an equation is like a balance in which the equation 2x plus 1 is equal to x plus 4. What I'm going to try to do is I'm going to try to isolate x to one side. So what I see here on the left-hand side is it's 2x plus 1 is equal to x plus 4. What I'm going to do, here's my plan. I'm going to develop a plan. I'm going to have x's on this side and my constants on this side. That is, I'm going to isolate my x to the left-hand side. So it's going to be done through a series of steps. So when I take a look at my diagram here, I don't really love this one. So what I'm going to choose to do is I'm going to subtract 1. And if I subtract 1, I need to keep it and subtract 1 from both sides to keep this in balance. Otherwise, one side will be heavier than the other. So what we have is 2x plus 1 minus 1 and x plus 4 minus 1. And we could simplify that so that it just looks like 2x, right? Plus 1 minus 1 is 0. And on the other side is x plus 4 minus 1, that is x plus 3. Now, I have a feeling that I'm almost done here. Now, I would like the x's to be isolated to one side. But when I take a look at the right-hand side, I still have an x. So I need to figure out how can I get rid of this x. And that is, well, I know what I'm going to do. I'm going to subtract x. But if I subtract it from one side, I'm going to subtract it from the other side. So with my equation, it was 2x. And then x plus 3. And then I'm going to just simply subtract x from both sides. And what I get on the right-hand side is 2x minus x is x. And on the right-hand side, x plus 3 minus x. Those are like terms, x minus x. And I'm just left with 3. Now, this is a little bit difficult and cumbersome way to think about it, always on a scale. But instead, let's internalize that. So I'm going to go for an algebraic solution. What I'm going to do is one piece at a time. The same thought is I'm going to isolate my variable on one side. Does it matter which side? No, I would suggest whichever side is easiest. And if they're both equally hard, may I suggest do it on the left-hand side. That is the convention. And my constant on the other side. So if I have 2x plus 1 is equal to x minus 4, what I'm going to do is I'm going to subtract 1 from both sides. Now that took a great deal of imagination simply because I would like to get rid of this plus 1. I'm going to subtract 1. So on the left-hand side, I have 2x. On the right-hand side, x plus 4 minus 1 is x plus 3. Now, if you notice here, to get rid of the adding 1, I subtracted 1, simply because they are inverse operations. Going down to the next step, right here, what do I want? I want to isolate my variables to one side. Well, I have variables on both sides, so I may choose to try to get rid of this x. Well, how do I get rid of the x on the right-hand side? is I'm going to subtract it. So here's my equation. Now it's x plus 3. What I'm going to do is I'm going to subtract x from both sides. And 2x minus x is just x. X plus 3 minus x is just 3. Now, I'm going to do it a third way, maybe more advanced, but for some people this rings more true. And it's actually being one step ahead. So here's my equation again. What I'm going to do is I'm going to move. Now it's weird, I say move to the other side, but really is I'm going to try to get rid of this adding 1 to the left-hand side. So what I'm going to do is I'm going to subtract 1 from both sides. Now it's implied here. Why didn't I do anything there? Well, if I knew that I was going to add 1, subtract 1, I knew the result would be 0. So that's why I didn't put it in. And my algebra looks a little bit neater now. And follows the exact same steps as before. Now, we're going to try to isolate the variable to the left-hand side. Well, what's stopping it? Well, this x on the right-hand side. So what I'm going to do is I'm going to subtract x from both sides. And if you notice, on the right-hand side, x just disappeared. And the reason for that is because I subtracted it. And what we have, 2x minus x is x. 3. A lot of people come to believe that when we move a number or a variable to the other side, it becomes the opposite. So that may come in, and that may not make sense to you right now, but as we progress, it is always using this balance strategies that we will solve.